Show everybody the secret to understanding mathematics, okay? All right, let's suppose you have a arithmetic sequence like this going on and on like that. Okay, now to get to the next term, 1 plus 3 equals 4, 4 plus 3 equals 7, 7 plus 3 equals 10. If I didn't know that, I could say 4 minus 1 equals 3. Okay, 4 minus 1 equals 3. I could say 7 minus 4 equals 3. I could say 10 minus 7 equals 3. Like that, right? Alrighty. So now here we got our first term called a sub 1 equals 1, right? Okay, we can also write this as a sub 1 equals a sub 1, knowing that a sub 1 equals 1, plus this common difference, 3, times the number of times we moved. Okay, if we haven't moved at all, at the first term, we haven't moved yet. We're stuck at the first term. So we've moved how many positions? 0. Okay. A2 equals, again, A1. I always want to use the first term when I do these things. Plus 3 times, how far have we moved in positions? From here to here is 1 position, right? So I'm going to put it here. A sub 3 equals A1, first term, plus the common difference, times how many positions have I moved now? Well, 1, 2. I'm going to put it here. And A sub 4, A sub 4 equals A1 plus the common difference, times how many positions have we moved to get 4 positions? 1, 2, 3. From here to here is 1 position. From here to here is another position. And from here to here is another. So it's only 3. Well, now I can generalize that. And I can say a sub n equals the first term plus the common difference times, well, this is always 1 less. If you observe this, this is always 1 less than this. So that means right here, the nth term is going to be 4 here. And this is going to be 1 less than 4, which is 3. So we got common difference times n minus 1. And I'm going to rewrite that as a sub n, rather, equals a1 plus n minus 1 times d. Well, does that work? Let me think here. Okay, I said a1 equals a1 plus 3 times 0. Well, 3 times 0 is 0, so let's just a1 back again. A2 equals a1 plus 3. A1 equals 1. 1 plus 3 equals 4. A3 equals 1 plus 3 times 2. 1 plus 6 equals 7. Okay, for the 1, 2 times we've moved. Okay, a sub 4, finding the fourth term, equals 1 plus 3 times 3, which is 1 plus 3 times 3 is 1 plus 9, which is 10 for the fourth position. Let's see if that's in the fourth position. 1, 2, 3, 4. Not the number of times we move, but what position it's in, okay? But what goes in these parentheses is the number of times we moved. We actually moved to get to the next position. So we moved from 1 to 4 is 1 movement, okay? But if we stay there, from 1 just to 1 is 0 movement. You didn't move, you just stayed there. So you got your first term back again. You move from 1 to 4, you're moving 1 position. Move from 4 to 7, you're moving another position. Move from 7 to 10, you're moving yet another position. So basically, in general, a sub n equals a1 plus the quantity n minus 1 times d. Well, let's see if it works. Let's find out what a7 equals. A sub 7, okay? That should be 1 plus, well, 7 minus 1 is 6. And 6 times 3. So A7 should equal to 1 plus 18, which would equal to 19. So if I go 7 positions up here, if I go 7 terms up here, 1, 2, 3, 4, 10 plus 3 is 13. 13 plus 3 is 16. And 16 plus 3 is 19. Okay? So that's one position, not movement now. One term, the second term here, third term, fourth term, fifth term, sixth term, seventh term is 19. We just calculated it as being 19. The same thing with our formula. I calculated it as being the nth term using my formula as being 19. So you know that formula works, right? So I mean, this is basic stuff, but this is what makes it interesting is how I derived it. If I move or if I don't move. If I don't move, then this one is the same thing as 1 plus 3 times 0, which is going to give 1 back. If I move one position, that's going to be 1 plus 3 times 1, which equals 4. If I move 2 positions, 1, 2, if I move 2 positions, 1, 2, that's going to be the same thing as 1 plus 2 times 3, which is 1 plus 6, which equals 7. See? That's how these arithmetic series work. Okay? So that is always how I thought about mathematics when I was taking advanced mathematics. I mean, this is just basic stuff, but the concept, the basic concept, this is how it works. Basically, you can take this into the advanced level of mathematics. And all you have to do is look at the first thing and determine when something is moving or when it is staying stationary. Okay? If it's staying stationary, it's moved 0 positions. If it goes to the next term, it's moved 1 position. You understand? But the term is always 1 less than the movement. Okay? The term itself is always less than 1 movement. Okay? If you don't move, you stay there, you're still at term 1. If you move, okay, you're at term 2, but you've only made 1 movement, which is 1 less than the term you're at. So that's how I looked at it. Okay, now, with that concept in mind, I want to rewrite that formula. I want to do something else. Okay? Okay, we said A sub n equals A1 plus the quantity n minus 1 times the common difference. Okay? Now, let's take the series. A1 is your first term, plus A1 plus D. This is going to be a series now. It's not going to be a sequence anymore. It's going to be a series because I'm adding. This was a sequence because I didn't add the terms. I just found the nth term using mathematics. But now I want to derive a formula for adding all these terms up. So the next term after that would be A1 plus 2D plus and so on, what we derived. A1 plus n minus 1 times D is what we derive. And we're going to call that the series, the arithmetic series, the sum of the arithmetic series. Okay, now I want to write that backwards. So I'm going to take this A1 plus n minus 1 times D. I'm going to add it to this. And then I'm going to add this to This is the last term. That's the last term. Next to the last term would be A1 plus n minus 2 times D plus A1 plus the quantity n minus 3 times D plus all the way up to the very first term, because we're going backwards now. Now, what happens, this is totally legal because I wrote it backwards. So this is totally legal. It's like you could add 1 plus 2 plus 3, or you could add 3 plus 2 plus 1, and you would still get the same answer. So that's the basic concept of this, okay? So now, what I'm going to do is I'm going to add these two together and try to find a generalized formula. So Sn plus Sn equals 2 of them, 2Sn. And this equals 2A1 plus n minus 1 times D plus, well, negative 2D plus D is just going to give your D back again. And A1 plus A1 is going to be 2A1 again. So you're going to have this, you're going to keep repeating this. 2A1 plus n minus 1 times D. And even here, if you look, negative 3D plus 2D is just going to be, it's going to be D again. Okay, so you have n minus 1 again. So you go on and so on all the way up to 2A1 plus this n minus 1 times D. So you have n of those, right? So now what am I going to do? I'm just going to write this 2Sn equals n times this 2A1 plus n minus 1 quantity times D. I'm going to close this. All right. Now I'm going to divide by 2, and I will have S sub n equal to n over 2 times the quantity 2A1 plus n minus 1 times D. Okay? And in another video, it takes a little algebra, but you can also prove that S sub n just equals the average of the first term plus the last term divided by 2. But your generalized formula here that I wanted to derive is S sub n equals n over 2 times the quantity 2 times a sub 1 plus the quantity n minus 1 times D. But now, if you think about it, if you watch this video, I would go back to the beginning and see how I derived this general formula. A sub n equals A1 plus the quantity n minus 1 times D based upon movement. That's the key word in this derivation, movement. What moves and what doesn't, okay? So if you're at the first term and you don't move, your movement's going to be 0. So A1 equals A1 plus the common difference times the movement. Well, you didn't move at all, so it's going to be 0. So A1 is still going to be equal to A1 plus 3 times 0, which is just A1 equals A1. But you keep this to generalize. A2 equals A1 plus 3 times the first movement to get to the next term, which is the second term, movement 1, second term, movement 1, A1 plus 3 times movement 1, and it's always 1 less than the term that you're trying to find, okay? And so I generalized and I said a sub n equals a sub 1 plus d times the quantity of the number of movements. The number of movements is n minus 1 in general. And then I rewrote it as a sub n equals a1 plus the quantity n minus 1 times d, the common difference. Okay, that's the generalized formula for finding the nth term. And this is the generalized formula for finding the sum of the arithmetic sequence, okay? Series, the arithmetic series. S sub n equals n over 2 times the quantity 2 times a sub 1 plus the quantity n minus 1 times d, which also can be written as S sub n just equals the average between the first and last term. Okay? So I hope this helps.